Bismillah ar-Rahman Rahim, June 2014, and we're in 42, question number 3. Okay, the topic is string attached, and we have available in the middle one particle or bead, you can say. Okay. Once again, I explained to you that in case if we have a ring available, ring. So this tension and this tension will be if someone is pulled here. So this tension and this tension will be 100% equal, though this length is bigger and this length is smaller. But when if we have not ring here, a bead or a particle here, then this tension and this tension will be different. So I think this point is very important and very valid. So clear. Now let's talk about a question. Mass is zero point 0.7 of this particle or bead into 10. I got this 7 newtons. Okay, we can see all three lengths are given. So using this one, I can find either is the angle, this angle and this angle I can find. We have find out the tensions in a string. Naturally, when someone is pulling this way, so tension will be this way, and they are different from each other. Reason these lengths are different from each other. Interesting part, if this length and this length same, okay, but even this force is this rate is not there, then we can say that tensions are equal. But even the mass is attached here, and these forces are equal, sorry, these lengths are equal, so tension will be not same, because due to this pull downwards, so the tensions the string will be different. So let's talk about this is theta 1, and this I call theta 2, and this I call T1, and this I call as a T2. So how to get theta 1? So I'm using this in front of this angle opposite. This is a hypotenuse. So I'm using theta 1 is equals to sine inverse 2.4 by 3. And if I take sine inverse and 2.4 divided by 3, so I'm getting this theta 1 is 53.13 for more accuracy. Okay. What about theta 2, students? Theta 2 is here. So I'll use these two. So same story, opposite by hypotenuse. So 2.4 over 2.5. So I'm getting theta 2 is equal to sine inverse opposite by hypotenuse. So I can call as this one as a 73.739. Basically, I'm writing 74. Okay, so this part is very clear. So this is the angle, I got it. Okay, both angle, I got it. Now I'm going to do the force resolution. This force is naturally parallel to the rod, okay? And this is theta 1, you can see, and because when two lines are parallel, a line cut, so these angles are equals to each other. So I can call this one T1 cos 53.1, and this will be naturally T1 sine 53.1. Same way, this tension 2, it has a two components. Let me show you the resolution. So okay, I show you this way, and this force here and one force downwards, and again this angle and this angle same, so I call this is a theta 2, and this I am writing now here. Wait a minute, this maybe create a problem. Okay, I'm writing here T2, and cos theta 2 is how much? That is 73 point. Okay, let me write it here. Wait a minute. Okay, this is 7 newtons. Okay, here I'm writing cos 73.74, and this is, I can call very simple. This is T2 sine 73.74. Now, students, I can do comparison. Okay, I mean, right side forces is equal to left right side forces, and upward force equal to downward forces. So, I have two choices. I'm writing here T1 sine 53.13 plus T2 sine 73.74 is equals to 10. So this one, this is called horizontal components. Horizontal component. horizontally. Let's talk about vertically. So the top is T1 cos 53.13 is equals to 7 plus T2 cos 73.74. Little bit complicated because like this is a T1 is here and T2 here and T1 here is T2. I have to solve them simultaneously. What is the method? I think so. We can choose, if I bring this down, I can make a T1 subject. So have a look. T1 is equals to 7 plus T2 cos 73.74 divided by cos 53.13. This is a T1 value. I'm going to plug in where? I'm going to plug in it here, T1. So let's try to do it. So put T1 value. A little bit algebra, complicated algebra, but not impossible to do. 73.74 divided by cos 53.13 and times to what? This is a value of T1 and times to this value will come here. Basically, it's coming in numerator. So sine 53.13. It will multiply up only, all right? And plus T2 sine 73.74 is equals to 10. Okay, students, so first of all, this multiply and this multiply. So what happens then for further, I can say here, sine over cos. Okay, I'm writing here 7 tan 53.13. How come? Because sine over cos, when it multiply with this, will divide by this, I get this form. And what about T2? So T2 cos 73.74 time to sine 53.13 and plus T2 sine 73.74 equals to 10. So students, what is common from here and here? T2 common. So I will bring this component on the other side. So let's try to do in one attempt. 10 is already there and divide by what? Divide by what? Because, sorry to say, this 10 minus this will go and subtract from 10. So I can say 7 tan 53.13. And from this T2 common out, what left? This left plus this left will go down. Look, I'm writing cos 73.74 times to sine 53.13 plus sine 73.74. I'm going to type in calculator, will give me the answer. 10 minus 7 times to tan 53.13, done, and divided by what? Cos 73.74, okay, times to sine 53.13 and then plus sine 73.74. And if I check in calculator, I'm getting here 0.563 newtons. I hope so the concept is clear. And this value, if I copy it here, I'll get T2 as well. So T1 as well. So I'm typing it. Time to cos 73.74 and plus 7 and divided by cos 53.13. And this giving me 11.92 newtons. This is my force tension number 2. So tension 2 is because tension 1 is bigger, yeah, naturally, and tension 2 is smaller because the particle, this is pushing downwards. So tension on the above string is naturally more, and tension on the lower string is a lesser. I hope so. The concept of the question is very, very